Welcome everyone. Am I audible? Great.
Hi, Kamla. Yeah, you're audible.
Yes, hello everyone. I'm so sorry for the delay. Actually, I'm at an event at the Ambedkar Hall, which is in Janpat, Delhi. So I think there was some network issue and I was a little late in connecting. So I'm sorry for that. And Abhishek, you are there?
Yes, I am.
Okay, great. So as I was saying that I'm so sorry I got a little bit delayed. I'm here. I will just
Mhm.
show this. Um, I'm here just in front of Baba Rao Bhimrao, Baba Saheb Bhimrao Ambedkar. I'll just show
Mhm.
this. Yes,
Wow.
I'm here. So I was in the Beam Hall and I couldn't connect from there. So I've just come outside to connect. And very warm welcome to everyone uh, to this day three of the online FTP program. And I've shared the presentations for the earlier sessions. And just to repeat for everyone's information, the attendance is on Zoom. You don't need to worry about that. You all need to finish the course on Future Skills Prime, which is DAF STEM, and join your group, which is AICTE Atal. And you need to join the group and then finish the course and then take the assessment. And once you take the assessment, then uh, your marks will be uploaded by next Wednesday. You have time till Sunday to complete the assessment, and marks will be uploaded by Wednesday. And after that, you give the feedback on Atal, and then you will be able to download your certificate. So I hope that's clear to everyone. And I'll now hand it over to Abhishek to take the session forward. Hi, Abhishek. I'll request you to come on camera.
I was speaking on mute. Sorry.
Yes. So I
Okay.
might just get logged out of the thing if
Okay.
I go inside the hall, but I'll request you
Hmm.
to carry on and I'll
Sure.
join back when the network. I mean, I'll be coming off and on, but you please take the class.
Okay. Sure. Sure. Okay. Let's get started. Everyone, can you see my screen? Mhm. Yes. Great. So, uh, what is visible to you? What do you see on the screen? Superb. So I think we have got almost 75 to 80 people on the call. Nice. London Bridge, great. Bridge, London Bridge, great. Great. So we have got almost 80 to 82 people on the call. Mm. Let's quick have a quick round of introduction. Probably you can just help me with your name, your city, location, or probably your profession. That would be great. Quickly, I am Abhishek. I have 15 years of experience in cybersecurity, data security, some part in AI. I am working in Bangalore. I live in Bangalore, and my native is Patna. So, everyone, please go ahead and just spare a moment for yourself, not more than 10-15 seconds, and help me with your name, location, your profession. That would be great. Wow. Everyone is professor. Nice. Gujarat, Karnataka. Okay. Mhm. Great. Got two, three response only. I think people have already got a long day, and and you must be thinking of this guy has come up at 6 p.m. for me, and this he will eat my 1.5 hours. Don't worry, I'll try to make sure you at least understand one thing in this 1.5 hour. And whatever I think I'll be taking care of. At least you'll have a good memory and you won't get bored. Okay, nice, nice. Getting good responses now. Superb, superb, superb. Okay, let's do a good exercise now. Before starting with the session, let's close our eyes for 5 seconds. Let's close our eyes for 5 seconds. I'll count. Five, four, three, two, one. Now open your eyes. Anything changed? Anything changed around you? In those 5 seconds, anything changed around you? Yes or no? Why you're in feeling fresh? Okay, nice. Nothing much. Okay, nice, nice. Go ahead, go ahead. Pour in your thoughts. Relax. Nice. Great. Eyes got relief. Nice. Cool. So your cameras are not on. You can keep your eyes closed whenever you want to. You'll feel nice. But keep your ears open. At least you should hear me for next 1.5 hours at least. You'll get at least one or two things really good to you, which you'd like. You can comment on that later on at the end, whatever you like. Any specific topic, any specific word you liked, or whether you disliked anything, you can feel free. You can just pop it here in the chat window if you don't like anything. If you like anything, pop it there and vent it out. I know it's late evening for all of you. For me as well, I was working as well, but I'll try to make sure we'll be having a good session. Okay, nice. So let me share. Screen is already shared. Let me start the slideshow. Okay, just a moment. Pop out the chat as well. Okay. I hope the slide is visible. And the first word you might be seeing here is the word cybersecurity. Bold, capital, everything, right? You can see my name twice, right? I like my name. Just kidding. Okay, so you can see the word cybersecurity, and that's why we are here for. Yes, I'll start from basic. Even I only know basics, so I can start from basic. I can be in the basics only. Okay, so you can see few other words as well, like think, secure, anticipate, identify, act. So what is cybersecurity? I'll talk about it. But these four words, think, secure, anticipate, identify, act. So whenever there is a word named cybersecurity or security, you see it. What comes into your mind? What is the first perception you get when you hear this word cybersecurity? Anyone? Anything? Mobile tapping? Okay. Let's categorize it. So when you say a word, what you perceive, will try to categorize like mobile tapping. It is a positive word or negative word or positive insight or negative insight. Okay. So mobile tapping, sometimes it is negative. I think negative sentiment, right? What are the other things? Let's come. Let's get it coming. Okay, secure all system connected to internet. That's positive. Personal data protection, positive. Okay, yes, negative. Okay, safe. So I got one negative, three positive now. Great. Protection against cyber fraud. Four positive, one negative. Intrusion is negative. Two negative. Okay. Protection five. Five plus five is to two. Privacy six. Nice. So 6 is to 2 is the current score. Out of 82 people, only 8 people have answered. At least we should have, I mean, this is just 10% of it. At least we should have 50%. I know people must be tired, but let's have some, let's spend this 1.5 hour really well so that we don't have to go back and think that we have wasted it. CIA triangle concept, yes, that is neutral. That is quite deep. Premlata, nice, but that's good. Safe data, then 7 and 2. Okay, nice, 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 nice. Let's get it coming. Security and privacy of data. Nice. This batch is actually good. I'm getting positive vibes altogether. Everyone is responding with positive in a positive way. Superb. Great. Okay. So you think some part of the answers are positive, some were negative. Okay. Nice. How it goes to it's absolutely a positive thing. Something which helps you to learn how to be defensive, how to be offensive, when to be defensive, when to be offensive. Thank you, people. So when we talk about cybersecurity, we should think of things secure. I mean, thinking something to be secured, anticipating in a good way, identifying the risk, acting on the risk, anticipating the threats, identifying the threats, and acting on the threats. Okay, these were high level. Let's go on the basics now. Uh, okay, so the first word, what is cybersecurity? I don't know how many people understand Hindi, but in the word in Hindi, in our schools, I had learned a thing like sandhi and sandhi with shade. That means sandhi is like to a matchmaking, joining two words. Sandhi with shade is separating them out. So that's what I have done here. You can see three different blocks, so three different icons. Let me use the laser first. Ah, three different icons: cyber security, right? If I would have written plus and then equal to, then people would have called me. Suddenly I'm doing splitting. Suddenly shade, right? Yes. So this is what it looks like from the English perspective. So cybersecurity is a word that comes up when we combine two different words. One is cyber, other is security. I know there are different meanings of these words. Cyber means something which is related to electronics, digital systems, computers, machines, something which is not tangible. Okay. So any data within your phone is not tangible. That is cyber, part of cyber, right? Your network is not tangible. It's a part of cyber, right? But when we try to secure it, then it's cyber security, right? There are different types of security you might have seen, like your physical security, borders, gates, bodyguards, police. Those are the part of security, right? For safeguarding the thing. So when you try to safeguard your data, your content which is not tangible on the systems, on the machines, on the servers, on the network, then it is cybersecurity. Okay. But when we talk about security, is it just safeguarding the thing? I mean, when we say safeguarding, people might understand that enveloping an object to keep it safe, we are enveloping that with a few other measures. Like, if, for example, if you might have seen, like when you have to secure a building, you are having having borders, boundaries. You are having guards. You are having security cameras. You are having fences, right? So these all are the part of physical thing. But when we go to cybersecurity, similar thing uh, are provisioned in the cyberspace as well, right? So, for example, for your phone itself, when you have a phone, you have if you have to safeguard your phone, the first thing is like you put the passcodes, right? You put the passwords, patterns, fingerprint lock, camera locks, and all, right? So that is one part of cyber security, right? Second thing is like you make sure your data is not wiped out, right? That is also securing your data, right? If your data is wiped out, then there is no security, correct? So ensuring that is not wiped out. So there are different mechanisms to do that. Different measures are taken for it. For example, to make sure data is not wiped out or the data remains available to you. You used to keep that on cloud, or keep the backup of those data into some other system or laptop servers, anything. So that is one way to secure the data, right? Third thing is availability. For example, your phone is all good, it's all logged, your data is saved, your data, you are able to access your data. But what would happen if you are not able to access your phone itself? That is not available to you. It could be different ways, it cannot be available. For example, the battery is drained out, or your phone, you have lost it somewhere, you kept it somewhere in the box, you forgot, someone has taken your phone there. So all of these comprise to the way of availability, right? That means your data, your system is not available, your data is not available, right? So this part also comes into the part of cybersecurity. Okay. Okay. But when we talk about all these things, data, cyber, people, availability, distractions, changes, access, this all are combines to or converges with three main characteristics, right? One of them is people, that is we, process, and third is technology. So the entire part is driven by these three strategies: people, process, and technology. Technology, I guess everyone would have understood that where technology comes into the picture, right? Your passcode, your phone, or your system, everywhere technology. It's all technology. Process is something you should follow some part of rules, regulations, or protocols to operate, to use, or to safeguard. That is called as process. For example, if you have to use your phone, you have to unlock it first, right? So that is a part of process. You have to, if you have to set the passcode, you have to follow some process or follow some steps, right? So that is a process, right? Or for example, you have to call someone, then you have to go on the call, like or call functions of the phone. You'll have to search the number, or you have to key in the number, and then you can dial, right? So that is a process, that is the steps which you follow, right? And all these things are done by people, we, you, me, you, everyone, right? So these are the three main core or in strategy of any cybersecurity. I hope I'm clear. If you have any questions, please drop in anytime, anytime. Okay. Okay. So that was a big lecture on cybersecurity. Now we understand why we need cybersecurity. Let's try to understand it. Why we need it. It's a big term, cybersecurity. Why why we are looking for it. So there are a number of reasons why we need something. But when we try to categorize, it falls into these six, oh, sorry, these six pillars. Okay. It is required for privacy and human rights, trust and reputations, cost and financial losses to reduce cost and financial losses, to build trust and reputations, to preserve human and privacy rights, to preserve critical infrastructure, or to safeguard critical infrastructure, to to adhere to regulatory and legal compliances, maintain business continuity, or in a nutshell, cybersecurity, you can see the nut, and that is in the shell. Cybersecurity is essential because it protects data, preserves trust, prevents financial losses, ensures operational stability, secure both individual and nation in increasingly digital world. That means every in the onset of the digital revolution, you can see that the dependency on the digital experiences or dependency on the system has increased more than ever, right? Every new day you'll find different new systems coming into play. Now it's AI. Earlier there were just plain systems, or even 10, 20, 20 years, 25 years ago, it was just a very small system. You get the calculator on the system, you use it, and that's it. But nowadays you have got AI which will do everything right for you. So the technology is evolving. There are ways to exploit the things. There are new ways being devised to exploit the things. So in order to protect that, we need cybersecurity. And when we say that in order to protect that, actually what it is actually protecting, right? The first thing you might have heard a few years ago, or maybe now even, like data is the new oil, right? So why how it is compared? Few years ago, or a few decades ago, we used to hear that petrol is liquid gold, right? Oil is liquid gold, petrol is liquid gold. But now it is said that data is new oil. That means earlier oil or petrol was compared with the gold, with the gold standard, right? Now data is compared to the oil. So it is at par of it. What could go wrong with it, right? If data is the oil, then why it is like that, right? You might have this question, like if people are saying that data is the new oil, then why it is said so? Let me give you a very small example. You might have witnessed these things as well in the news, right? Like people are getting morph videos, morph photos of celebrity of someone, right? In fact, morphed audios of people, and people are trying to call someone with the morphed audio and try to get money with someone they are calling, and then try to get money. So these are the misuses, right? How they are misusing? When if someone is trying to call someone else and try to get the money, he's providing few data. For example, you might have heard about the digital arrest, right? In the phenomena of digital arrest, you might have seen that someone is calling you, or not calling you, sorry, someone is calling person with showing him like he's some authority, and he says that I have got this information. He knows the name of the victim, he knows the age of the victim, he knows the phone number of the victim, he knows the view where he is residing or she is residing, who lives around. All those informations are known to them, right? That's why they are so confident, right? But how do they know it? Isn't that a breach in privacy? If they are knowing it and they are illegitimate, if they are knowing through one mean or other, isn't that a breach of privacy or a breach of human right? It is, right? And if that is the case and they are calling on behalf of some reputed organization, isn't that the trust in that organization is lost? Or if they are asking for some amount, some capital, some fund, some money, then there is a financial loss cost involved to it, right? So these things are interconnected. If you go and tap one thing, other things can pop up, right? So in a very high level, if it go with cybersecurity, we try to preserve all these six pillars: privacy of human rights, trust and building trust and reputations, cost, financial losses, and make sure it doesn't happen, safeguarding infrastructure, adhering to law and regulations, and maintaining business continuity. Okay. Okay. If you can think of something like what could be the average cost of data breach, it is in millions. So when I say about data breach, that means there have been data breach in the past as well, where organizations lost their data by one way or the others, and they had to pay hefty fines through hefty fines impounded by legal authorities, government, or one way or the other. Other thing is like in nowadays, you can see your technology or systems has come so close to you. That means that you cannot remain agnostic to it. For example, have a few years ago there was one news in US. People were not able to access the power. There was no power in the US homes. I don't remember the state for almost 36 hours. And the reason was the system which was managing the power grid was people were not able to access it and they lost the control over it. So it was a total sabotage, right? So someone is sitting miles away, 10,000 kilometer away in in the separate location in the world, and probably they are able to they are able to seize the power grid in some other nation which is very far away, right? So that is you're able to do it, or the person is able to do it. So that is the power of internet, and that is also if with the great power great comes great responsibilities, right? So every now and then we are covered or we are enveloped by the technology all around. For example, you have smart bulbs now, smart switches, smart cameras, your voice assistant speakers, your phones, your systems, everywhere. Technology all together. For- Think of someday you have your home automated. You come to your home and your vacuum cleaner start working of itself. Your switches, your AC, your bulbs start glowing itself. You'll feel good, right? When you come back to your home, if AC, your home is uh, already already cool. You have lights glowing. It feels really plush, right? But think of the next minute when the starts blinking on its own. You came at your home, everything worked fine. Your lights glow up. Your AC started. Your TV started. All good, looking good. Your favorite music started. You're feeling good. But very next minute, your lights or bulbs start blinking. Your TV starts behaving abruptly. It's getting started, then stopping, or your voice assistant started working abruptly. Then that would be a spooky situation, right? But when you learn it, that it could be done from millions or miles away by someone else, then that is more spooky, right? So, in order to make sure that these things works of its own, I mean, with your authority, this cybersecurity is required. Okay. Okay. Let's get going. Any questions, anyone till now? No one. Great. I'm really good instructor. Means person intervention by Anjali. Okay. Person intervention is one part of it. The reason why I took this example is to make sure that you understand. That is one way of it. If I would have taken a different example, which may not, you may not be able to connect to it. But yeah, person intervention is one of the things. But it could be a commercial as well. It could be a global as well. I'll talk through those examples as well when I'll be going through the further slides further. Some examples which happened globally few months ago. Um, I'll take those examples as well. But yeah, it's just not personal, but on other aspects of life as well. Okay. So let's talk about CIA tried. Someone had pinged about CIA when I asked about the security. Really thanks to him, her. Sorry, I forgot the name. But yeah. So whenever we talk about security or cyber security, information security, everything has is connected with or observed with these three letters. CIA. Okay, this is not ISI or RAW or any secret agency. It's just CIA, which means confidentiality, integrity, and availability. Someone can call it CI as well, like confidentiality, availability, integrity, but it is just it is used in one way or other, but it all falls to CIA. Call it okay, or confidentiality, integrity, and availability. Entire security domain is built on these three words on the top of it. Okay. So when we call about confidentiality, that means to prevent or protect a sensitive information. A sensitive information could be something for one, something for someone else. For example, for a student, sensitive information could be his marks for him, right? Which he may or may not want. For one student, his marks could be sensitive information for him. For the others, it could not. For example, if someone has scored really less, just at the brink of passing, he may not want to show his marks to his team, his home, his relatives, his parents, and all, right? It may or may not. I'm not saying that he will not, but it may or may not. That is one case. But if someone is topper, he may not like to show his marks to anyone. The school will flash it. So is that private anymore? No, right? So for entire confidentiality is subject to privacy prevention of sensitive information. Okay. The second example could be your passwords, your salary slips, your account information, right? You may like to share your banker name to other people, but would you like to share your uh, this bank balance or your salary information to anyone else? No, right? It's private to you. It's sensitive information for you, right? So prevention of security of sensitive information comes falls into confidentiality. To maintain the confidentiality, okay? To keep sensitive information sensitive and not public. To keep the sensitive information confidential and not public. Okay, there are different ways to do it. I have a different slide for it as well, like two-factor authentication and all. I'll go through it. But let's go to integrity, the second part. When we call about integrity, what does it mean? Integrity and why it is required actually. Okay? If we go by word, integrity is nothing but to make sure whatever information was there preserved. There has not been any change in that, or any unlawful or there has not been any adulteration in that information. That is called integrity. Why it is required, right? The reason why it is required is, let's take the example of the same boy who don't want to show his marks, right? Or let's take the example of the topper whose marks are available to everyone. You can take either of them. Let's take the example of topper, right? If he has got 90% and someone go back to his home and they say that he has got just 70%, there has been change in his marks, right? Actually, I mean, not the marks, actual marks, but the conveyance, what is conveyed to the parents, right? So just 70%. But actually he was having 90%. He secured 90%. So there has been change, right? So that means there has been some adulteration in the information, right? And that was an unauthorized adulteration because someone who has told that 70%, that would not be authorized to provide that information because the marks is of that particular student A, right? Similarly, in the example of a student who has got less marks, if he has got 35, he has just passed, and someone go back to his home and say that he has got 20 marks or even 50. In 50, he might get happy, but even he will say that someone will say that he got 20 marks, right? Then that is again an alteration, right? Any alteration in the actual information, actual data, right? That means the integrity of data has been lost, accuracy has been lost, the trust has been lost, right? That's where integrity fall into. We also call it repudiation, and we try to when we try to preserve it with one way or other, we call it non-repudiation. That means nothing has been the data is accurate. It has not There has not been any change in it. Okay, you might hear this word repudiation, non-repudiation as well, because this is used very usually when we talk about digital signatures. So doing a digital signature is a way of preserving integrity. Okay, when you sign something digitally, you get you say that this the integrity you have signed something digitally, and at the receiver end they can check if there has been change in the actual data or not. That is a possibility. Okay, so that's how integrity is maintained. And the third one is availability. Okay, some of you might have question why availability, right? So if the data is their systems are there, information is there, but no one is able to access it, then there would be availability, right? One of the very recent examples, I'll give you two examples. One of the recent example is the crash of Indigo, not the plane crash, but the system crash in December, right? People were stranded, right? Because the planes were not available, system was not available to them. They had the ticket, they were not able to go, they were not able to fly. Similar experience thing happened a year or 2 years ago when most of the world's airlines were grounded because of an issue at Windows, right? They were not able to process, they were not able to function. That was also a type of lack in availability or attack in availability, right? When the system is not available. So at any point of time, you'll be able to work or you'll be able to continue with your things only when it is available. Confidentiality will be there. That means you have to prevent the insensitive information. Integrity can uh, will be there. Will Integrity will be lost when there is any adulteration or alteration. But when there is no availability, the entire system is not available, right? So, in a nutshell, this CIA tried availability, confidentiality, integrity. If any one of these is compromised or lost, we call it a loss or compromisation of security. If your confidentiality is lost, your security is compromised. If your integrity is lost, your security is compromised. If the availability is lost, your security is compromised. And when we talk about it, it's always zero or one binary, whether it is lost or not lost. It's not like partial confidentiality has been lost. It's always zero or one. Okay. Okay. Any questions? Feel free to come. Okay. Then we have different key domains of security. That is network security, application security, information security, operational security, disaster recovery, and cloud security. These are very high level three different, sorry, six domains of security. In the network security, it all talks about computer networks, intruders, firewalls, VPNs. Feel free to drop any word if you don't understand. For example, if I'm talking about firewall or VPN or SQL injection prevention, if you don't understand any word, feel free to drop it. I'll explain it. Okay. So network security talks about securing the networks, not only computer networks, but the entire network, right? Server network, router networks, and all. It could be done through different ways like firewalls, VPNs, intrusion detection systems. There are preventive security. preventive measures, proactive measures taken on all of the security. When you go through security, it's all about like measures. It could be preventive, corrective, proactive, all kinds of measures. Okay. When we talk about like application security talk, it gives us overview about the applic keeping the application secured from threats. The threats could be compromising the data, compromising the logins of it. For example, what I've written SQL injection prevention. Let's say you when you are logging to the website, you provide your user ID and password. All right. Yes or no? When you log in, you provide user ID or password or not? Yes or no? I don't think anyone is providing user ID and password. Okay, Dipti saying yes. Okay, sure, Jagat. Okay, great. So when we talk about, I'll come back to you, Jagat. You have asked about how and what level firewall and antivirus works. I'll come to it. Okay. So for example, when you provide user ID and password, you're keying in your own password. Okay. How password is checked? It goes back to database, check the password, comes back, right? But let's say if I've instead of providing a login user ID, I'll just write a SQL query there. Select star from the username where user from a table, something like that. Okay. And system actually gives me the result back with all the usernames, right? Then what does it mean? It is like querying within the database where the users are actually stored. So that is SQL injection. That means you're trying to use SQL to read the database from the read the data from the table of the login user, and system is actually to allowing you to do that. That is application security to prevent that thing. That is application security. Another example could be your cross-site request forgery, CSRF. What does it mean? It means, or cross-site scripting even. It means a malicious act, you are trying to log into the bank's website. A malicious actor is sitting between you and the bank. Whatever you are sharing, sending, a malicious actor is able to, a third party, you can say, is able to read that and able to change it on the fly, right? It is able to do that. That to prevent application from those phenomenons, application security comes into the picture, right? Um, then the information security. Information security is the big domain actually where it talks about everything like protection of integrity and privacy of data, protect your physical security, software security, storage, logging, monitoring, everything. It comes under information security. That means to secure information anyway, wherever it is there, whether it is in the building, whether it is in a system, whether it is in the pocket of someone, just securing that, whatever possible way, that comes into information security. It's a bigger domain. All other domains are a part of it, but information security has the maximum reach across all the domain. Okay. Then the OPSEC or operational security. It is basically the process or to safeguard the process and the decisions for handling any system. For example, uh, uh, last year there was Operation Sindoor, right? There was an attack in India, and for some days, everything people were working, or the defense forces were working, government was working. But were they leaking everything in the public domain? No, right? And that was not required too, right? What they wanted to do, when they wanted to do, it was all process, right? So was that required to make sure the process are safe? Was that required, yes or no? I think it was required, yes. But safeguarding the processes, safeguarding the decisions, protecting the data assets, or protecting the permissions to access the network, all comes under operational security. Okay. Then disaster recovery and business continuity. So in recent years, I think 5 6 years ago, there was a phenomenon occurred across the world which actually activated the disaster recovery mechanism phenomenon of all the organizations or of all the government in the world. What was that? I hope everyone is older than 5 years, more than 5 year old, right? So, or maybe more than 10 years old. So you can think of, right? So tell me what was the phenomenon occurred 6 years ago, which actually activated the disaster recovery mode of every organization, every uh, government across the world. Think. No answers? Think. Data outage? Did it happen across the world? Think of it. Something happened 5 6 years ago, and it actually triggered everyone to start their disaster recovery process or business continuity process to run on their disaster recovery way. What was it? Everyone, every organization had to do it. Every government had to do it. Think of it. What happened 5 6 years ago? You might have heard about NDRF, SDRF, that is State Disaster Recovery Force, National Disaster Recovery Force. You might have heard about. That is one part. I'm not correlating with the my question, but something happened. Information leakage, no. Data outage, no. What was it? Think of it. It was really known to everyone. Window crash, maybe? No. Come out of system. Come out of system. Come out of phone, come out of system, come out of servers, come out of Windows, come out of memory, come out of servers, come out of laptop. It was something which affected everyone. What was it? What happened 5 6 years ago, which touched each and everyone's life? Corona, yes. Yes. It was COVID, Corona, the beloved coronavirus, which actually enabled or triggered everyone or forced everyone to trigger their disaster recovery mode, right? What was the normal thing before COVID, right? Everyone else used to go to office, everyone knew, children used to go to school, people used to work in shops, uh, government was doing their work. But what happened? Train was working, airlines were working, everyone was okay, everything was okay. But suddenly everything got halted, right? Everything halted. Most of the things, I would say. Actually, in the initial few weeks, it was everything was halted, right? Schools were closed. They started with online classes. So what online class was? It was a disaster recovery mechanism or business continuity thing. That means even if things we don't have the system, we don't have the building, still the students were reading, they were studying, right? That means studying was going on in spite of the phenomenon that occurred, in spite of disaster came up, right? Work from home, yes. And so that was the TR mode activated for office work from home, right? Even people who wanted to go to their homes, the trains were not there, or flight were not there, they walked it to their home, right? What this that was? That was they are trying their persons or people's disaster DR mode were triggered in every office. Like people used to go to office and work, right? But after COVID and before COVID or during COVID, people started working from home. That was the DR mode. You might have heard, few people might have heard that we have been able to we have gone into DR mode and now we'll be working from home or like that. Organization had these kind of communications as well. So in order to make sure the business continues in the terms of in the event of disaster as well, or how to recover the business from the disaster if there is a disaster has happened, that is one of the domain for cybersecurity as well, where we study about it. Then the sixth is the cloud security. By the way, what is cloud? When we think about cloud, what is cloud? Anyone, any answers? What is cloud? Might have heard about it. Cloud data, cloud computing, cloud storage. What is cloud? Anyone, any answers? Hmm. Anyone, any answers? What is cloud? Think of it. Don't Google. If you want to Google, you can do it. But try to think of it first. What is it? It may be wrong, it may be right, but at least give it a time, give it some few seconds to your mind to think of it. Okay, Badal, nice. Availability in everywhere. Okay. Okay. Online data centers. Okay. Every time, everywhere available. Okay. Big storage, centralized database storage. Nice, nice. Kind of remote data storage on internet. Okay. Okay. Nice. I've got few things. Few good answers. Nice, nice. Hmm. Online data is useful for maths. Okay, cloud is useful for maths. That is something unique I've heard. How it is useful for maths. Nice. This is the first time I'm hearing it. I'm looking it. Useful for maths. How? I'll need to think of it. Think of it. Okay. Okay, fine. Internet instead of on your device. Okay. Nice. So one of the answer was online data center. That is, yes, that is one part of it. Okay. Big bucket of storage. So yes. So actually cloud is the collection of all these things. Like you have your application, you can have your infrastructure on cloud. That means you can get your machines, your system on cloud and install your app or operating systems like Windows, Linux, anything. You can have your infrastructure on cloud. You can have your storage on cloud. For example, you buy hard disk to store files, you to store photographs, right? You can, instead of buying that, you can buy some storage on the cloud, and then you can use that as a storage, maybe 10 GB, 15 GB, whatever requirement you have. You can use it. That's in that case, yes, it's a data storage, but it is not just not data storage. It can have infrastructure, your infrastructure, you can have systems, you can have servers, you can have your routers on the cloud, you can have your switches on the cloud. That is possible. So infrastructure is there as well. You have your storage, yes. You can also host your application there. Okay. For example, the Instagram you're using, or the Facebook you're using, your website like Flipkart, Amazon you're using, everything is hosted on cloud, right? So for them, cloud they are using for applications hosting, infrastructure hosting, usage of infrastructure. So cloud is a combination of your uh, different infrastructures, different data storage units, different you can store as files, you can store the databases, you can have different instances of databases as well. You can host your application, you can use the application hosted by the cloud as well. So it's a combination of all these things, and this entire operation is called as computing. Whenever you are hosting an application, you are hosting your infrastructure, you're hosting a database, you are doing some calculations there, right? That's where the word computing came up. So in a nutshell, cloud is a distributed system which hosts varieties of uh, uh, resources for users, and it also facilitate hosting of applications, storing of data, and many more. So it's a combination of it. So it is important to secure that, secure all those functions, applications, system, databases. So the branch of cybersecurity or info security which talks about these is called cloud security. Okay. Okay. So there was one question about antivirus and firewalls, right? Please talk a little about how and what level firewall and antivirus works. Okay. So the firewall works. Firewall, what a firewall is? A firewall is nothing but a kind of gatekeeper between your system and the external world. Okay. Firewall will only work on the network. That means whenever something has to go out of your system or that has to come into your system, then firewall will work. Okay, so it is a part of network. And antivirus, what? But before understanding antivirus, we need to understand what the virus is. Okay, virus is nothing but a program designed to access the files which is actually not required to be accessed, or manipulate a file, or to read those files or access those files which are not required. For example, when you use your Windows, your operating system, your Windows, you'll go when you go to your C drive, you'll find different folders there, like sysperf or program files or Windows files. Windows. When you go inside those files, when you go to Windows itself, when you try to fiddle around in any of the files, your system may start experiencing issues. It may not work properly, right? That's what virus can do. But the thing is, like, they may able to access those files, or which it doesn't has to do, but it will not spread automatically. It will only be able to access whenever you grant the permission, or it is the file is infected. Okay. So a virus is prone or more associated with the files, folders, and data. But firewall is associated with the network. Okay, that what which port or what who can connect, who could not connect. That is associated with firewalls. I hope that's clear now. Yeah. Okay, let's go ahead. Now, when I was talking about confidentiality, I had one line mentioned there about, then that was securing the data core, right? And it was all about mentioned like two-factor authentication. You might have heard about two-factor authentication, multi-factor authentication, or so, or you might have been using in your current systems or current setups as well, in your school, in your bank accounts, in your colleges, or maybe in other websites you might have been accessing. That at that point of time you might have experienced or used this as well. For example, when you are logging to mm, Instagram, right? Or when you are logging to IRCTC as well, right? When you log into IRCTC, it asks for three things, right? The first is your username, the password, and third one is your captcha, right? The second way is you can use OTP as well, right? So at any point of time when you log into a website, what is common? What you will find everywhere? Username, right? Your phone number or username or email, right? That is the first driver to it, right? The second one could be your password you enter, or you can enter your PIN, right? Once you go with the sign in button, it triggers for OTP, right? It may trigger for OTP, or if you are using on phone, it may trigger for face scan, your fingerprint scan, right? What these are and why these are, right? So in the domain of multi-factor authentication, it's all about authenticating someone, or when I say authenticating, that means what authentication is actually authorizing someone, is checking someone whether someone, sorry, effective, checking someone if that person or user is a legitimate user to access the actual content or not. Okay. So for example, if I'll log into your to my bank account and I've put my user ID and password, but I've when it opened in the back into system, it is showing me bank balance of someone else. I've logged in as Kumar Abhishek. When I went into, it showed me is the data of Shashi Kumar, Anjali or Suganti, anyone, right? So is that correct? I think no, right? But how system will know that you are the correct one who is trying to access the data? Because there is no Ram Lal sitting behind who will say that, okay, this is the guy who has come here and he is trying to access the data. It's not like that, right? Systems are agnostic to anyone. They don't know us. They haven't seen us, right? How system will know that this is the correct guy or this is the correct person who is trying to access the data or who is trying to access the system, right? So in order to understand this through by the system, this multi-factor authentication or uh, these three main uh, uh, I would say tools have been derived. Like something you know, that means something you already have, something you have, so that means that is something in your possession. Something new, that means something that is in your mind, actually. Something you have, that is something is in your possession, and something you are, that means you that is something which cannot be removed from you. No one can remove fingerprints, or no one can mimic your fingerprints, right? Even tigers have a different unique patterns in their fur or in their skin, right? That all are unique, right? No one can change it. Face scan, iris scan, these are mostly unique. Your iris, your face. There are different cases like cosmetic surgeries, that is a different thing, but in general, yes, iris scan, voice is unique, iris or your eyes are unique, your face is unique. So these are the part of factors that something is a part of your knowledge or your possession or inherence. When we combine either two of them, when we use any two of these characteristics while authenticating into the system, then it is called as a multi-factor authentication or two-factor authentication. Okay. Two-factor, multi-factor authentications are used hand in hand. Okay. So whenever there, at any point of time, when at the point of authentication, when you're having these two things, something you know, something you have, or maybe something you know, you're using password as well as fingerprint scan, or you are using just one-time password and face scan, or just you are using password and OTP, then this it is called as multi-factor authentication. Make sense? Okay. Okay, if it is making sense, let's have a small quiz. Everyone, can you please scan this particular QR code and answer one question. Please go ahead, scan this particular QR code and answer the question. There is only one question. I'll give you this time. Have to close everything in la next 20 minutes, and there are a few more things. So this is the time you can think of. You can spend some time. I'll give you 2 3 minutes to answer this question. Go ahead, scan and answer the question. Great, great, great. Let's see. Okay, barcode is not working for you. Okay, let's see. The link is on the. Okay, I'll share that mm, in the chat as well. Wait. Just a moment. Let me share the link in the chat. Thank you who have done it. Yes, so here is the link in the chat. Okay, I cannot see the results somehow. Let me put the question here as well. I can see almost 20 people have said yes, and around 8, 9 have said no. I'll put the questions here as well. Wait. Okay, I put the question here as well, so that who is not able to put in their answers or are not able to answer, not able to scan, they can see the questions here. Done. Yeah, I can see many of the people are saying yes. Nice. Mm, nice. Great. Actually, great. Let me. Just a moment. Let me log in here as well. Okay, I can see. Uh, there are a large number of people who have said yes, and that is actually great. So the people who have said no, let me explain the scenario. Or to the people who have said yes as well, let me explain the scenario. So scenario is you are going to the bank, to your bank branch, your own bank branch, and uh, you have taken your self check. Self check means a check which is signed by yourself. That means you have gone to the bank branch, you have taken a check to withdraw some amount, and the check is signed by you. Okay, that is from your own account, not others' account. Okay, that means so if you do it when you go to bank and with the self check, then is that a multi-factor authentication or not? Many of the people have said yes, yes. If it is yes, then how? And if it is no, then how? Valid ID and OTP to my mobile is necessary. But when you're going to a bank branch, there's no OTP or mobile as such, right? They may ask me out, but when you're just going with the self check, with the check, then what are the factors associated here? Thanks, everyone. I really got good response this time in this session. You guys are rocking. Amazing. Nice. So, when you are going to branch, what you did, you took a check, right? The check has your account number written on it, right? That means you have a check with account number. That's something you have. You have signed it as well, right? That means something you know. Know your signature, right? But when you go to the officer, you give him the check. What he does, he will go to the system, key in your bank account number. Then what he does, he will do this, right? He's trying to match something from the screen, right? What does he matches? What is does he try to verify? Yes, verify the signature. That means something you know. Your signatures are registered there, right? That means something you know. So something you know is ticked, yes. Something you have checked with your account number mentioned there, it is ticked. But what is another major factor? They also check your photo. They check your photo in the system and then check you, who is in front. Because if it is self-check, if someone else will come up, they will not give the amount, right? They will verify the face matches the person who is standing there. The face of this person matches with the photo that is registered in their system or not, right? So what is the major factor here? This is you, yourself, your face. First factor is signature. That is right. But the second or the major factor is you yourself, right? So they are trying to verify these things. Even in the case like the photo is very old, they will ask your ID proof. It may be Aadhaar, driving license. That is secondary one. But ideally, the factor is you yourself, the face and signature, because it's self-check. Self-check. The self-check, no one else apart from you can withdraw money from the bank account if it is self-check. Okay, it is you. So the factor here are your signature and you. Make sense? Are you all with me? Any questions? Any disparity? Anyone saying no? I will go my face covered, or anyone will say no, I won't sign the check. If anyone wants to do that, do at the bank. I cannot do anything. Okay, let's get going. Okay. Okay, where is the laser? Laser. Thank you. You guys are amazing. Okay, so we talked about different securing security, defense, everything. Now let's talk about threats. So, in the space of cyber, there are different types of threats. A very easy one, or everyone would have an experience, is social engineering or phishing, right? A social engineering is something when one of the real life example is you go. to a mall, someone comes to you with a coupon and say that, sir, this is the coupon which will give you 50% discount or 50% off in your next movie ticket. Or you'll get a movie ticket with this when you fill your phone number and name and put that in a box, right? You might have experienced this. What they're trying to do, what they're collecting from you, what important information, your name and your phone number, right? You might experience when you go and actually put your number and details, they don't, you got the movie whether you see or not, that's a different thing. But you start getting calls like, sir, do you want to have this credit card? Do you want to buy this house? Do you want to see, get that plot? Do you want to go somewhere to travel? Ultimately, you'll get the bombarded with these calls. How they got your number, right? So they don't got it. You actually provided them, right? So that is one way of social engineering. Again, this digital arrest is is a way of social engineering, right? All these frauds which are happening, that is a part of social engineering altogether. It's very, very, very known to everyone in real life. You cannot see a Trojan. Hello. Uh, you cannot see a Trojan, you cannot see a ransomware, you cannot see adware, spyware, scareware. You cannot touch it. But social engineering, you can touch the people. It's touchy, right? Apart from that, yes, Trojan, worms, virus, ransomware, adware, spyware are the different threats. Few others are man in the middle attack when someone in sitting in between you and the bank and tries to between two parties and try to sneak in the details or data, steal the data that has been man in the middle. Denial of service when a system is flooded with overwhelmed with the request and it is not able to respond. That is in denial of service. One of the example you might have heard is like not now, but almost a decade ago when big Flipkart launched its first big billion day sale, right? The system crashed. Though all the requests were legitimate, I won't say that is the attack, but that was one of the scenario where the system was not able to respond. It was not able to service. It was in a denial mode to service. It was not able to do that. Okay. That's not a very good example of denial of service, but that is one of the things which you might have heard about it, saw it, or read somewhere. Right? So overwhelming a system or flooding a system is with so many requests that it is not able to do access or it's not able to respond or service, then that is denial of service. Okay. Then if SQL injection, I already told you about that. Zero day exploit, something which is like a day zero, something has came up and no one knows about it. For example, there was a case when 2000 note was introduced. There was a scenario when a student just took that 2000 rupees note, got that colored Xerox photograph, colored Xeroxed or colored copied, and he used it. It was kind of zero day exploit. No one knows how that note looks like, and people were using it. And that actually got used. There was a case like that. So that is kind of zero day exploit. Like there is any vulnerability which has come into the system and no one knows about it. And only attacker knows about it, got its information from somewhere. Then that is zero day exploit. Okay. This is very high level information where the percentage of phishing or social engineering uh, actually happening or happened in the different states. I got this information from data protection. There's one organization, data protection organization or DP organization of on on their website they have put it. Which talks about that 80 to 95% of human associated breach uh, is due to phishing or social engineering. 43 to 58% accounts for Trojans. Ransomwares involve 44%. Adware is very very common. You might see in your apps as well. When you try to open an app, you'll find ads one way or other that is popping on screen somewhere on the screen. So that is the adware. Worms and viruses, again, 88% of the current malwares are worms and viruses. Spyware is something, any app or any program which is try to sneak your data, spy on you, then that comes into spyware, where user is not able to understand that he's getting spied, but things are there. Spywares are there as well. There few next gen threats are identity threats, advanced threats, mobile device threats, infrastructure threats, ransomware evaluations, tech vulnerabilities. Everything is interconnected in somewhat or other, or maybe evolution of few older threats. One example is deep fake videos, deep fake photos, enhanced social engineering, data poisoning, adaptive malwares, cryptojacking, fake government apps, and many more. Okay, I'll give you these slides so you can just go through it as well. Then we talk about user data control. I think I only have 5-10 minutes now to quick it. User data controls. Okay. So whenever we talk about, we have heard about, there was one in the slide I had talked about regulations, right? Regulatory bodies, regulations. Why these are? What is the function of why we need them regulations, right? So what they do is they design few rules, few protocols, few standards, which everyone has to follow in order to make sure the control of the data, your data, remains to you. You should know what of your data is being fetched by the system or the organizations, how they are used, till when they are used, what is the purpose of it, and when you ask to delete them, they should be deleted. This is what all these regulatory bodies defines. They set the rules based on all these things. They take your consent when your data is collected. You should be get the consent should be clear, informed. It can be withdrawn anytime. The minimal should not be like you have to open a bank account, then they should ask your blood group. They should only ask your PAN number and name and the data, address and all, right? So minimal data should be acquired or fetched. Rights like you should be able to access the data which you have provided at any point of time. You should be have access to get your data erased or rectified. Accountabilities like they have some duties on your data. That means it should be safeguarded, should not be hacked, or it should not be compromised. Then the storage retention, if for example if you have taken loan for 5 years, the data should not reside for them for next 20-25 years, right? So there should be some timelines for storage and retention of it. Purpose, like for what purpose the data is being acquired. And the notice, like for why, when, how long are the rights of the person whose data is acquired, right? All these are part of data controls, which is governed by regulatory bodies. In India, it's DPDPA, GDPR. It actually applies to entire world, but it is mainly from Europe. HIPAA is for for health data, and CCPA is California Consumer Protection Act. That is mainly in the US. PCI DSS is Payment Card Interface Data Security Standard. That is not a regulatory body, but industry-wide practice for safeguarding the credit card data. Okay, card informations. Safeguarding data. So when we talk about data controls, how we can safeguard the data, there are different ways like encryption, securing the storages, monitoring, auditing, classification, incident response, backup recovery, access controls in one way or other to safeguard your data, to make sure that it is not accessible from unauthorized accesses. Okay. Security operations. I'll show you a quick view of the security operations, which talks about everything what is done to secure the data from one point to other. For example, digital investigations, logging and monitoring, incident responses, key operational processes, BCDR, that is business continuity and DR testing, disaster recovery processes, physical security controls, which talks about bollards, walls, fence, docks, personal safety like privacy, incursions and travels, incident response would be recovery and repair, problem management. All these things are the part of security controls. Okay. So, in a very high level, the next is adaptation. How are you going to adapt it? One way is locking
We
down
are
your system.
almost on time
Yes.
now. Aditya, I mean, Aditya has also joined us. If you can
I'll
just
just
wrap
stick
up.
to for yeah. I just have one more. This is the last slide. I'll just
Okay,
take
if you
2 more
can just
minutes and
wrap
we
up.
should.
Yeah. Okay.
Yep.
Okay. Thanks.
Okay. So the best ways to adapt is like lock your system, adopt the zero mind trust mindset that we should not trust anyone, patch everything, practice data resiliency, have the backups. Don't use avoid the Wi-Fi without protection. Avoid open networks. Defend your endpoint. That means defend your phone, defend your phone, laptop, systems, cameras, everything to be compromised. Okay. And this is the road we are traveling on. Thank you for it.
Thank you so much, Abhishek, for that uh, cybersecurity training. I think everyone benefited, and thank you so much for joining us.
Thank you.
Uh,
And from every one of you, I just need one word or one topic which you understood well. It could be any word which I would have spoken multiple times in this 1.5 hours. Just one word of it, whatever you took from this session, and that's it. Okay.
yeah, you can put it in the MFA.
Yeah. You can put it in the chat. Yes.
Yes, please put it in the chat. Yes. Thank you so much,
Thank
Abhishek.
you.
And I'd like to now welcome Aditya Johar, who's joined us from Orange Mantra.
Okay.
Hi, Aditya. Welcome. You can come on camera.
Hi, Kamna.
Hi, am I audible?
Yes, you are.
Yes. I was just telling everyone that I joined from Ambedkar International Center. Today we have a event here, and that's why I might be coming on and off because of the network thing.
Okay.
So yes, but I'll uh, just introduce you, and then you can take it from there.
Yeah,
So
not.
yes, so Aditya has been uh, closely working with NASCOM for not just online sessions but also offline physical sessions. He is senior software architect at Orange Mantra, and he is, his sessions are known for a lot of hands-on training and giving real examples. So make the most of it. Uh, just engage and interact and make the best possible use of this time. So over to you, Aditya.
Thank you so much. Thank you. So, thanks, guys. I will be conducting this session for cloud computing and edge security today. And just in the middle, I just want to let you guys know that I might be out for 2 to 3 minutes because there's a little bit of work going outside. But apart from that, we will have a fully engaging session. And we will begin. Let me share my screen and let's talk about cloud computing and edge security. So I see we have 207 attendees today, which is good number. And I hope, or if you have some background with cloud, that will be fantastic. If not, this you can consider this as a first session. I will keep things as simple as possible and as easy to understand as possible as well. So just a quick request, Abhishek, if you can stop sharing your screen so I can begin sharing. Yeah, thank you so much. All right. Okay, so what we've got here now, we will be talking today about cloud computing, security, and edge devices. I did see that my colleague, Mr. Abhishek, was talking a little bit about security and disaster recovery in the previous session as well. So I will be starting from a little. Let's consider that from a from the initial standpoint, where cloud computing has come from, and what cloud computing is. The origins and how it has grown over the past. You know, about I would say it's around 20 years old now. Cloud computing as an industry essentially started in the mid 2000s. One of the pioneers was AWS. So we will try to have as engaging as session as possible. So I would like to first ask a question to everyone over here, that how many people have worked on cloud before? You can just type in the chat, or you can I think if you have the ability to raise your hands also, that's also possible, or else you can type in the chat, and that will also be very beneficial. So I would like to first ask everyone, how many people here have worked on cloud security before? Only theory. Okay. So Chitra says only theory. Dipti says not worked. How about others? Not worked. No, no. Okay. Not a problem. Not a problem at all. All right. So how about, how many people over here have know what a server is, or have, in your colleges or your enterprises or companies, you would have seen, uh, okay, somebody says we use cloud to save Zoom videos. Okay, not worked. All right. Okay, so yeah, so definitely saving Zoom videos is also a little bit of a part of cloud itself. Um, but we will be talking more about technical aspect. So has anyone over here seen a server room in your colleges, in your enterprises, companies? You would have seen some server rooms, where you have these large multiple desktops, computers, all. Okay, fantastic. So many people have seen server rooms. All right, all right. So now when we talk about cloud computing, you can imagine that it is a server room, but it is not hosted within the premises of your college, or your company, or your physical location. You can consider it, that's why it's called cloud computing. The server room is hosted anywhere else. However, uh, it's still a server room, and the maintenance of that server room, when we talk about, when you have a server room, you need to have, you need to have electricity, you need to have cooling in that, you need to have, it should not be very humid, all of these things, it's a very cumbersome process to manage. Then you need to keep it secure, you need to, and typically up till about 10 years, or even today, of course, but all these companies, and where you used to have server rooms, they would have many multiple IT admins. They would have people taking like ensuring that everything is up to date, all the security is in place. But now all of those things are maintained in the cloud. So when we talk about cloud computing, you've got your infrastructure as a service. So this can be those actual physical servers, instead of your physical server room that you have in your company and in your organization or in your college. The physical hardware is now owned and maintained by Google Cloud, AWS, Azure, and so on and so forth. However, on top of it, now you have the platform. So you've got the hardware that is maintained by, let's say, Google, AWS, Azure, or any of the other cloud solutions provider like DigitalOcean, Hostinger, and so many other ones that are there. Then you've got the platform as a service that sits on top of it. So what are the services they offer? They offer, let's say, virtual machines. We will talk about in depth what virtual machines are. We will talk about databases on the cloud, storage on the cloud. Somebody just mentioned a moment ago that you've saved Zoom videos on the cloud. So storage, that is also a platform as a service. They're giving you storage locations on the cloud where you can store your files, folders, and so on and so forth. And finally, on top of it, you've got your final service, which is how you're accessing it. So for example, Gmail or Slack or Zoom, all of these things is right at the top. So you've got your infrastructure as a service, platform as a service, and software as a service. Now, guys, you will need to give me 2 minutes. I will be right back. Give me 2 minutes and I will be right back. I just need to get something done. There's a little bit of work going outside. I'll be right back. Thank you, guys. Thank you. I'm back. Thank you so much. I just needed to get that little thing done. Okay, let me reshare my screen. Fabulous. So what we had seen, infrastructure as a service, platform as a service, and software as a service. Infrastructure, imagine those physical server rooms that you've seen in your college and your companies. Those are the same things, except they are in a location that's owned and maintained by Google, Azure, AWS, or any of the cloud providers. Platform, you can consider, even Google itself is a platform. Google Cloud is a platform. AWS is a platform. And finally, the software that's sitting on top of it, which can be Gmail, Trello, Slack, and so on and so forth. Now, coming to why did cloud computing actually begin? And how it began, what was the challenge that, if we consider, we can really consider AWS as the main pioneer of cloud computing in today's world. However, in today's time, Google, Azure, and AWS, all three offer the same, kind of services. But cloud computing began when Amazon, to a great extent, they were building their e-commerce business. Today we've got Amazon all over the world. In the early 2000s, they were building their business, and they realized that to build their business, they needed to be as proficient in the retail and sales part of it, equivalently to the hardware and server management part of it as well. So they needed to be very good at managing, when they've got, let's say they start a sale, a flash sale on their website, and suddenly 1 million people come on the website, and now they need to ensure that the servers don't crash. Or they decide that, okay, we are going to launch not only in the US, but we're going to launch in Canada as well, or we're going to launch in Europe as well. And suddenly they realize that, okay, our servers, which were earlier only sufficient for US, they need to now be expanded to also support Canada and to also support Europe and so on and so forth. So they gained a lot of expertise in maintaining, managing, controlling, owning servers. And when they gained that expertise, they realized that the problem that they were solving was also a problem that thousands of other enterprises were facing. Managing and maintaining server rooms was a really big process. It was not easy. So when they realized that they had solved this problem, they decided that, okay, we've got our e-commerce business, we will continue with that, but we will also provide cloud computing services to companies who do not wish to maintain or own server rooms. That's one. Second is, there are many companies who cannot afford a server room, but they want to provide digital products. So many startups today, if you ask them that you need to maintain a whole server room to offer your product, they will not be able to afford it. But because with cloud, and we'll see in just a short while what kind of pricing we are looking at for some of the cloud computing services, suddenly the server room, which has now moved to the cloud, becomes very, very accessible. It's very accessible, and it's very easy for companies to just pay, a few thousand rupees a month, and you've got your servers ready. Earlier, these costs used to be in the lakhs of rupees. So a lot has changed. Let's take a look at the three major clouds that we've got today. And all these three major clouds, whether it's Google, it's Azure, and it's AWS, they offer more or less the same things. But because cloud has matured so much, today, if you go into the websites, you can see that they have pre-packaged solutions. So let's say you want to build a e-commerce or a retail startup. What would you do? You would look at their readily available solutions, retail. You would click, and it's gonna tell you what they have on offer for retail, right? Available for you. Similarly for cloud computing, similarly for AWS. So out of everyone over here, I would like to ask, how many people have some ideas for a startup? You don't need to share the ideas, but you can just tell me how many people have ideas for a startup. Ideas for startups, guys. Ideas for startups. I'm assuming everyone has some or the other idea for startups. Even if, or you would have at least seen some startups some small companies that are working really hard to try and grow. So they are able to utilize these pre-packaged solutions and are able to use the cloud to build their startups. Let's say you have an e-commerce idea, or you have a app idea or something like that, something of that sort. You can literally go onto these platforms, and you can build what you require in just a few days in today's time. So let's come back to a little bit of a technical side of the discussion. Since we have, I've given you an overview of what the cloud is and where it began from, in terms of converting those huge server rooms, very difficult and costly to maintain, moving them into the cloud. So now one server room essentially is shared by hundreds or thousands of people, which today we call them data centers. But essentially, at the core of it all, it's just a server room. Now they call it a data center. Where did it all begin, and what's the real core technical concept at the heart of it? So if we look at, right at the center of it all is what we call a virtual machine. So a virtual machine is basically what you have right at the center, right at the heart of the uh, uh, concept which is required for any cloud computing service. Now, what is a virtual machine? 10, 15, 20 years ago, when you had those server rooms, you typically had one server, and those servers, either they could be horizontal, in nature, or they could be one of those desktop-like servers, which, they look like a desktop computer, but they have a software inside which acts as a server. What a virtual machine is basically the same server. It's the exact same thing, but the only difference is that instead of that hardware being there, within one hardware, they have created multiple shared, like Anjali here is mentioning, shared resource, VMs, shared OS. They have created multiple virtual machines within that one hardware. So what that allows us to do, let's say I have an idea for a startup and or for a website, and there are 5 other people who also want to build their website. These cloud providers, they use, let's say, one server itself, but within that server, they've created 5, 10, 15, 20 kind of server machines, virtual machines. So it allows 10 people, 5 people, 20 people to communicate with only the software that they have put into the hardware, without affecting the software that is running for the other customers or other users. That's what a virtual machine is. So it's basically a machine inside a machine, or a partition inside those servers. That's what a virtual machine is. Now, looking at, when we look at the different kinds of virtual machines, earlier when you used to go and you used to buy your or even today when you buy a desktop computer, or you buy any laptop, or you even if you buy your own server, you always see how much RAM does it have, what is the kind of CPU, what is the memory in that server, or in that desktop, or in that laptop. So a virtual machine has the same concepts that sit inside. Now, talking about one of the tools that I always use is the pricing calculator. So this allows us to see, and all of these services, they have their pricing calculators. Within the pricing calculator itself, you can you can see all the different kind of services they have. So essentially a compute engine. Now, the virtual machine, the name of a virtual machine is different for each of these cloud providers. Like Google calls it a compute engine. Azure will call it a Azure virtual machine. AWS calls it elastic compute. So the names are different, but essentially they are still just a virtual machine. So what is a compute engine? A compute engine is a secure and customizable compute service that lets you create and run virtual machines on Google's infrastructure. Compute Engine includes the following services: instances, sole tenant nodes, machine images. But let's click on this and let's see what are the different kind of compute engine or virtual machines that they offer. So you can always select number of instances and how many instances you want. You want 1, 2, how many virtual machines essentially that you want, and what is going to be the total usage time per month. So are you going to be using it, let's say, you can specify here in terms of days. You use it for the entire 30 days per month, and you've got one instance, 0.9. So it's just a calculation thing. And you select the OS that you want. So it's just like selecting an OS in your, when you buy a laptop or a desktop, it's just like selecting an OS in that. So you can select a free OS, which is a Ubuntu, Linux. These are free OSs. Then you've got paid, you've got your Red Hat Linux, you've got your Windows Server and SQL Server, depending on your use case. But let's see when you pick your free OS over here. And then you have your provisioning model. So the difference is just a regular, and you can always click this. But basically, a spot is you pay. When the traffic comes into the server, but this makes your server run a little slow. Or you can have a regular one that's fully available for you the entire month. Machine type. Now, this is like you are selecting the kind of machine. So what this means is general purpose, compute optimized memory. So depending on your use case, let's say you want to just build a simple website, 500,000 people using it, you can use a general purpose VM. Compute optimized, let's say you have some, you've got some heavy tasks that need to run in the virtual machine. Then you would use a compute optimized. Memory optimized, where you want a lot of memory, you want a lot of RAM in that. And accelerator, these are the ones where you've got your GPUs. So when you want to perform AI analysis and stuff like that, you would use your accelerator optimized. So you can select a different kind of machines that you want. Let's say you pick a general purpose one. Then inside the general purpose one also, you've got different options. So what this means is you've got your high performance, consistently flexible cost of. It's like selecting your processor. So Intel i5, i7, i9, or AMD. So this defines what the processors are. And let's say you select a consistently high processor, and you can then finally select a machine type. So how much RAM do you want? How many vCPUs do you want? So let's say you picked one with 4 vCPUs and 15 gigabytes of RAM. And finally, so now this is your cost per month. So this, for a fairly good machine with 15 gigs of RAM, 4 vCPUs, good series, consistently high performance, you're getting around 10,000, 11,000, 12,000 rupees per month is your cost. But if you use just the very basic one, and you just went with like 2 vCPUs and 8 gigabytes of RAM, it's $66 a month. So it's around 5,000-6,000 rupees per month. You can always just specify. So clouds now, as you see over here, you can just use this slider and you can specify how many vCPUs you want, and let's take a look at the cost going up, and how much RAM you want. In about 20 years ago, if you needed to do this, you needed to actually buy that expensive hardware, with all these CPUs and RAM. And then, it would have cost you 20 lakh or 30 lakh rupees, just, or maybe even more, maybe, 50 lakh rupees about 20 years ago to get this kind of a configuration with 300 gigs of RAM and almost 60 CPUs. It will cost you maybe 50 lakh, 60 lakh rupees 20 years ago. Now, and maybe you only need it for just 2 months. So there was no point in buying something for 60 lakh rupees. Comparatively, you can just, when you need 60 CPUs and 300 gigs of RAM, you can pay, 2.5 lakh rupees, and you can get this, for a month. If you need it just for a month, pay your 2.5 lakh rupees, use it, and then just switch back to, your lesser configuration. And that's it. So you pay only for what you use. A few more, configuration settings. You can set the region where you want. So they offer data centers in India as well. They've got one in Mumbai. They've got one in Delhi. and so on. And then finally, there's a little bit of discounts that they offer. So now you can see that a basic virtual machine for a month, you can pay, around 6,000 rupees a month, and you can get a virtual machine ready for you. A little bit of the pricing also depends on the license. So if you use a Windows server, it costs more, because then you've got your Windows license cost also bundled into the VM. But instead of buying a desktop computer, which might cost you 40,000-50,000 rupees for this kind of a configuration, and maybe you need it only for, and then you need to also keep it on, you need to maintain it, you need to have all those things in place. Here you just pay for what you use, and that's it. So the pricing across the three clouds is similar. I would suggest play around with the pricing after this over the next few days. See how the pricing differs across the clouds. But this definitely is a good tool to use, because in the pricing calculator, you can of course see the pricing for virtual machines, but you can also see the pricing for different. So somebody mentioned that you've got your pricing, you use storage on to store the Zoom meetings. So let's say you wanted to buy a fixed amount of storage from Google per month of 5,000 gigabytes. So that's 5 terabytes per month. You would pay $100 a month, and you could use this standard storage. But let's say you just wanted 100 gigabytes per month, and that's $2 a month. So 100 gigs, $2 a month, and that's it. You can even you can specify regions. You have a lot of options that you can leverage when you're using in the cloud. But it's not that expensive. If you try to buy a hard disk today, 1 terabyte, it comes for about 5,000, 6,000 rupees. So here you pay $20 a month, and you get that 1 terabyte. And maybe you don't need to, you only need it for some time. You don't need the full hard disk, and it's all maintained on cloud. So that's another service. You've got a lot of different services that they offer. But playing around with the pricing calculator is a great way to understand the different services that they offer. Databases, BigQuery, cloud GPUs, TPUs. TPUs are also used for processing AI. Then you've got all of these different Cloud Run. We'll take a look at what serverless computing means also in a short moment. So lots and lots of options are available when you look at all of these things that are available in the cloud. And same way, you've got, even in Azure, you've got all of these different things. You can select compute, networking, storage. All of these are available on all the three clouds. So it's worth a look to go through the pricing calculator, because that allows you to see the different kind of services that are available. Any questions so far, guys? Would love to take a moment. Any questions? So we've seen what is available on the cloud. We've seen on where the cloud started from, how your server rooms became your cloud computing platforms. And would love to hear a little bit from you guys. You can put it in the chat if you have any questions so far. Any questions, guys? No questions? Okay. Somebody is Dr. Julie. She says very informative. Thank you. We will now proceed, and we will see something. What we've seen right now is virtual machines. And essentially what you do on a virtual machine, you would deploy your software, and the cloud provider would give you this space on rent. So I'll give you the analogy. Let's say when you rent a virtual machine, what you get is, let's say you want to rent out a parking space. in your building or in your society, and your parking space, and you say that, okay, I will pay 5,000 rupees a month, and this parking space is for me, it's dedicated for me. So whether I'm using it or I'm not using it, I'm still paying 5,000 to ensure that whenever I want to use it, it's available for me. Nobody else is going to park there because I've paid 5,000, I have reserved that spot. But let's say that you only use that parking space for 3 days in a month. You don't live in that society, maybe you live somewhere else, but you don't have an option that, you don't want to get caught in such a situation where you do go to the society and you find that you don't have a parking space because they didn't have any space available for you when you got there. So that's where you pay the, what we saw for the virtual machine, $60, $100 or whatever, whatever is that, you pay that fixed price per month and you get that server space rented for you for the entire month. But digital platforms and digital products are not essentially like that. Or even when, let's say, you go to the mall, you only pay for parking that, those 3, 4, 5 hours, 6 hours that you were there, you pay parking only for that. Mall doesn't ask you to pay parking for the entire month just because you were there for six hours. So that's how the idea of serverless computing came into the picture. Now, when you use a virtual machine or when you rent out a virtual machine, the entire hardware is available, is there for you to use if you want to, or if not, but you will be charged because they have reserved that space for you. But when you talk about serverless computing, let's say you know that your users will only come to your website on every Friday for 2 hours, and rest of the week they are not going to come to your website. So why should you pay for the full month? Now, that's where serverless computing came into the picture, where what the cloud providers said that, okay, put your source code in the cloud, but pay only for the amount of traffic that you get. Now, each of the cloud providers, they provide serverless computing. They provide that. I will use Google as the example, but all the three clouds provide serverless computing. If you see with Azure, you've got Azure Functions, process events with serverless code. On AWS, you've got Lambda. So the product is called Lambda on Azure, and on Google Cloud, it's called Cloud Run. So what does the description say? It says Cloud Run allows you to run front-end and back-end services, batch jobs, deploy websites and applications, and queue processing workloads without the need to manage infrastructure. So essentially, first 20 years ago, we had server rooms. Then the cloud companies came. After the cloud companies came, then they got they moved all the servers to the cloud. Then they provided us with virtual machines. They said that, okay, don't buy the entire server or the hardware in your location. Take virtual machine for rent. Now they are saying that don't even take a virtual machine for rent. Just put your code in the cloud, and whenever people want to use it, pay only for that amount. Now, what benefit this has is that your cost gets significantly lowered. So we saw that for using the virtual machine with 2 gigabytes of RAM or 4 gigabytes of RAM and 2 virtual CPUs, it cost us about $60 to $70 a month. But let's say people only use your website on Friday evening when you, for example, post your lecture notes. That's when they go to your website. So they want to download your notes, and that's the only time. Rest of the week, people don't use your website. So, and you know that only 1,000 people are going to use it. So let's say, you know that only 1,000 people use your website in a month. And you can override, your things like how many resources you want. So similar to the virtual machine, let's say we use the same configuration as the virtual machine that we saw earlier, 2 CPUs and 4 gigabytes of RAM. But we know that 1,000 people are only going to use it in the entire month. Look at this cost. It's only 2 cents for the entire month versus almost $65 for the entire month. when you used a virtual machine. So there is a huge difference when you use a serverless computing. So what is serverless computing? It allows you to deploy your application on the cloud, but you pay only for that traffic. And the benefit of this is that what the other problem that happens when you use a virtual machine is, you've only paid rent for that two virtual CPUs and 4 gigabytes of RAM. But suddenly, let's say you have made one website and it goes, it gets very high traffic. And suddenly there's, instead of 1,000 people, you see 1 million people have come to your website for whatever reason. The virtual machine will crash because it doesn't have any more resources than that two CPUs and 4 gigabytes of RAM. But here, when you go with serverless, it will automatically scale up to provide the services. So you don't need to do anything. If 1 million people start using your application, you don't need to do anything. 1 million people use your application, and look at the cost. It's $20 per month. It's still cheaper than that virtual machine that you had built. And you can even go very high over here. You can go up to 8 vCPUs, and you can use up to 32 gigabytes of RAM. So let's say you had some heavy processing jobs. Your cost is $94 per month for 1 million requests, with 8 CPUs and 32 gigs of RAM. So look at, it's still much cheaper. Now there's some limitations. Of course, it's not like serverless computing completely removes the the requirement for virtual machines. There are still use cases where, let's say you have some complex programs. There's always a limitation to the amount of complexity that you can deploy inside a serverless compute. But for most general use cases like websites, APIs for apps and stuff like that, for most general use cases, serverless computing works fabulous. It works fantastic. Now, talking a little bit about serverless computing, you can use this in, all these cloud platforms allow you to deploy your serverless compute in multiple programming languages. Node.js is very popular. Python is very popular. Typically, monolithic applications like Java and C++, they don't work very well in serverless environments because they require so many libraries and dependencies. But modern languages like JavaScript and Python, they work extremely well in serverless computing. So if you're looking to build websites and apps and you want a very cost-effective solution, think about going serverless, because that allows you to easily maintain your infrastructure and also have your cost lower. So that's what serverless is. Why go serverless? No operations. You don't need to manage any servers. Auto scales. It goes from 0 to thousands of requests instantly. And you don't pay for any idle capacity. If you're not using the parking space, you will not be charged for it. You only pay for the execution time. How much ever you are charged, how much ever you use, that's what you're charged. So that is what serverless computing is. In the past 5 to 6 years, this has become very, very popular and very, very common for a lot of use cases. Now, so like I mentioned, the serverless AWS Lambda is there, Azure functions are there, and cloud functions are there. These are the three products that they offer on the cloud for serverless compute. Any question on serverless compute, guys? Is this clear? The difference between serverless compute and virtual machines. This is if we always think about the parking space, that's a very good example that allows us to understand. Any questions? No questions? Okay, let's proceed. Then, let's talk a little bit about what is an application. And most of the applications today, when we talk about, let's say, a website, mobile application, dashboard, ticketing system, or e-commerce, anything, all of these applications. Most applications have three things. One is the front end. What does the user see at the presentation layer? That can be your website, the portal, that can be the app. Then third, it can also be a hybrid, but we won't talk about it. We'll keep the overview simple and non-technical. So let's say any application has three portions to it. One is the front end. The second is the back end, the APIs and such. And the third is the database. So we've seen you can deploy your front end and back end to virtual machines. You can deploy front end and back end to serverless compute as well. The third thing is the database. So where does the data for the users? So let's say you've got, you're running an e-commerce website and you need to maintain where the data is stored for all your customers, all the orders that they have placed, all your product details, all, the customer email IDs, names, phone numbers, so on and so forth. You need to have a database where you can store all this information, and so that all this information can be easily queried. So talking about that, the cloud also provides, apart from virtual machines and serverless compute where you can deploy your front end and back end, they also provide cloud databases. So you can have a full managed database system on the cloud where this entire data is going to be sitting, so it can be easily queried, and you can do analytics on it and so on and so forth. You can also use a virtual machine and you can deploy a database inside that as well. So you could take a virtual machine and you can deploy a database in that. You cannot deploy a database in serverless compute. Why? Because serverless compute, there is no server. There is no rented space where you can host your data. And because there is no rented space where you can host your data, there's no place for you to put your database. What is a database? It is information at rest. It is data at rest. It should be available for you when you need it. But serverless compute, the concept itself is that when there is no need or when it's not being used, it doesn't exist. So it will delete itself and there won't be any data that remains. So you cannot host databases in serverless computing, but you can host databases on a virtual machine. You can also host databases using your cloud database, managed database services. So when we look at the services that they provide here, this is a Cloud SQL. It's a fully managed database service that helps you easily deploy, manage, and scale your relational databases. Cloud SQL includes the following services: MySQL, Postgres, and SQL Server. So there are three most popular and most common databases that are used in the world are MySQL, Postgres SQL, and then you've got SQL Server. The difference between them is MySQL is an open source, free to use, no license cost database. It's a little slower than the other databases that are available. And the reason for it is, of course, it's not as powerful, but for most use cases, MySQL works fantastic. When you need something a little more robust, when you need something a little more performant, so that, how do you measure the performance of a database? You measure it in the time it takes for you to get the response from the database. When you query something, like, for example, you query, show me the data of all the users in terms of name, email ID. So MySQL, let's say it takes 1 second. Postgres might take 0.5 seconds. SQL Server might also take 0.5 seconds. SQL Server is Microsoft's database, Microsoft SQL Server. Postgres is a more performant, more heavy database managed by the Postgres the foundation. And then you've got MySQL, which is actually owned by Oracle, but it is provided for free. There is another database called Oracle database, but that is not provided in Google Cloud. And Oracle databases are much more expensive, but the reason for that is that they are also much more performant. So let's say you take a MySQL database, open source, and let's keep the region as, let's pick Delhi, or we can pick Mumbai, let's say Delhi. And let's say you've got your Cloud SQL edition, so Enterprise Plus. There's slight differences between two in terms of the availability, performance, and the speed of the data that you get. Let's say you use it for 730 hours a month, and here again you can select the kind of machine you want for your database. So what does that mean? Let's say you have only 1 GB of data. You don't need so many vCPUs, and you don't need so much RAM. You can just use you just use the basic you just use the basic setup. So 2 vCPUs with 7.5 gigs of RAM and enable high availability configuration. What this means is that it keeps a backup of your database available, so that if anything wrong happens, if there's a crash or anything in your main database, you will have a second database readily available to take place of your existing database. So if you enable high availability, your cost definitely goes up, because now you've got two databases that are a mirror of each other, but you've got a backup available. And you can then, of course, say the storage type. So when you buy a hard disk in today's market, also, if you buy an SSD, it is like 3 times more expensive than your HD. If you use an HDD, it will bring down your cost by $20. Now, high availability means you're essentially maintaining a backup of the data. Again, if you change this to a SQL server, cost goes up. It's like double the cost, $593. If you go with Postgres, it's like $115. And the reason for this is there's a little bit, it's cheaper on Google Cloud to use Postgres. They've always been very Postgres friendly. Some of the SQL queries are a little different on Postgres, but it's a very, very performant database. It's also a SQL database. And if you're looking to build enterprise grade scalable applications that can scale to millions of users, Postgres would be your database of choice. In my deck, I also speak a little bit about the other kind of databases that have become really popular in the past 5 to 7 years, which is the NoSQL database. So SQL database, you can imagine SQL databases like Excel sheets. They have columns, headings, names inside, and so on and so forth. Whereas a NoSQL database is not like that. It's not a tabular database. It's not something that you can see in tables. NoSQL database is a database that scales horizontally. What do I mean by it scaling horizontally? There is a format known as JSON, JavaScript Object Notation. Is there anyone here who knows what JSON is? JavaScript, it's called JSON. Anyone here who knows what JSON is? JavaScript Object Notation? Okay, no problem. So the difference between a relational database and a non-relational or NoSQL database is NoSQL database, the data is stored in a it's called a collection and document format. So after this session, you can take a look at what collection and document format is. It's a modern way of representing data. And these clouds also allow you to store your data in NoSQL format. So there are some very popular databases like MongoDB and Firestore that is available on Google. That's a Google proprietary database. Firestore here. Yeah, Firestore. So what does it describe for Firestore? Let's take a reading of that. Easily develop rich applications using a fully managed, scalable, and serverless document database. So basically, you can imagine that instead of a tabular structure, which you have in your SQL databases, in your NoSQL database, each user, for example, you've got a database of users with their name, email address, phone number, and so on. Each user in your SQL database will be like in an Excel sheet. In one row each, you will have your user. However, In a NoSQL database, each will be like a document on its own. So it will be like a simple, very, very lightweight document of one user, name, email, phone number listed over there. And then you will have another file, like you can consider it like a TXT or a document per se, but essentially it's very lightweight. Read up about collections and documents, that will help you, and understand a little bit about JSON, JavaScript Object Notation, JSON format. So you have your Firestore database as well. And here everything depends on the amount of reads and writes that you have per day. So let's say you store 50 gigabytes of data and you've got 2 million reads per day, 2 million documents are being read per day, and 300,000 documents being written per day. You would pay $324 per month for it. Now, this is for Firestore, which is a NoSQL database. There's another very popular NoSQL database. It's called MongoDB. That's another one that's really popular. Take a look at that as well. So when you want to store, sometimes storing unstructured data, it's very difficult to store unstructured data on SQL databases, because they have the requirement that everything should be in columns. Each column should have its. You can't put phone number in the name column. You can't put email ID in the phone number column. Everything needs to be structured. However, in a NoSQL database, you don't need to follow that same structure. Let's say you have a user who has name, email, phone number, and address, but another user has only name and email. They don't have phone number and address. So you can store different kinds of data in the same collection, and you can query it accordingly as well. So there's a real big benefit and real great benefit to using NoSQL databases, and they are very fast and performant as well. So these are the two different kinds of databases you have. You've got your structured SQL database, and you've got your unstructured, which is your NoSQL database. A little bit about when you are storing data and when you're using data. Security is very important, especially when you're storing personal data of customers or personal data of users. You want to have security in place as well. So each of the clouds offers something which is very core concept. It's called encryption at rest. It means that when your data is stored in the database on the cloud, all the data that you've got, it is essentially in encrypted format. So for example, if some thieves went into the data center and they were able to steal those servers that Google or AWS or Azure had, and some thieves went in and physically stole those servers, they will not be able to read the data that's inside it, because all of that data sits in encrypted format. And typically, the encryption and decryption keys are not hosted in those same servers. So even if somebody stole those servers, they would not be able to read any of the data because it is encrypted at rest. So data, if you see here, in data encryption, Google Cloud encrypts data in transit in between our facilities and at rest. So it's good to read about what encryption at rest means. It means that your data is stored in encrypted format. It's can't be read unless and until somebody has the decryption keys, and those decryption keys are stored in different locations by the cloud providers, so not very easy to get access to those. Also, there's another concept for cloud security, which is called IAM. IAM means identity and access management, IAM. Now, there is a policy that we should follow when we are using cloud. So let's say you have a team of multiple people and 8 people in your team, and let's say you own a Google Cloud subscription or an AWS subscription, and you hire 2 HTML developers, then you hire 2 Java developers, and you hire 2 Python developers, and you ask them to build separate applications. But the Python developer doesn't need to have access to the HTML developer's code or HTML developer's project. The HTML developer doesn't need to have the access to the Java developer's project. So what you would do is you would follow the principle of least access or zero trust policy. So what you would do is, instead of giving all of your team members access to your entire cloud, you give access to the people only for the resources that they are working on. So that is what is the concept of identity and access management, IAM. Each of the clouds provides IAM guidelines and best practices. So you can always go, search here as well, IAM, and search on AWS as well. Oh wait, in the product. So this is for securing your. So implement the principle of least privilege. Give people access to only those things which they need to access. You don't need to give access to everyone for everything. And when you are looking to maintain compliances like ISO 27000 and maintain compliances for all of these other SOC2, GDPR, DPDP, HIPAA, and so on and so forth, some of these most basic things that they require are these IAM policies should be in place. Along with IAM policies, it's also very important to have logging and monitoring. So you need to also, when you're using cloud, logging is extremely important. You need to monitor what's happening with your services. So you can always use, each of these clouds provides logging mechanisms. So you can see who accessed your server, who accessed your resource, when was the last time somebody logged in, and so on and so forth. So that falls under securing your infrastructure. You need to have some encryption, PIIs, personally identifiable information should be secured. Then you need to have your IAM policies in place. You need to have your logging and monitoring enabled. For example, ISO 27000, it requires you to have logging enabled, so that if there is an incident, let's say there's a data breach, you can always check the logs that what exactly happened during that data breach. So the log should be available for you. If you don't have logging enabled, you won't be able to see it. All right. So we also took a look at data backups. So earlier when we were looking at databases, we saw that you can have high availability databases. Disaster recovery, so DR. So let's say if one of your servers crashes, how do you get it back up? That falls under DR. So follow the 3-to-1 rule. Keep 3 copies of data on 2 different media types with 1 copy offsite. So essentially what this means is keep 3 copies, keep 1 copy, which is your primary copy. Then select a different region in your cloud provider and store the backup in a different region. So for example, if there is a mishap, if let's say there is a fire in the Delhi data center in Google, you have your data that is also stored in a different location in Mumbai, for example. So you have 2 different regions where the data is stored, and you can always recover the data. You are not limited by just the data being in one place. And the third aspect is that also store your data in an offline mode. So for example, for any reason, you lose access to your cloud, to your login credentials. For example, you've forgotten your password, you've forgotten your you don't have access to the phone number or email address where they send the verification. Everything is, you're not able to access it. At least you have an offline copy of the data that you've downloaded and stored somewhere. So that allows you to, get back up and running in case you ever lose your cloud data. There's another also thing that's that's popular amongst enterprises. They use multi-clouds. So they sync data between clouds, and they have accounts with Google, AWS, Azure, with everyone, and they sync the data between the clouds. So that's also one thing that's really popular, but not very common. I mean, it's not very common, but it is used in certain instances. Maintain snapshots. So let's say you've taken a virtual machine on rent, maintain snapshots of that VM. So let's say you want to revert your VM back to what it was last week. Let's say you push some new code into the virtual machine today and it's gone wrong. It's not working as expected. So you can use a snapshot to revert back to the working to the working mode of that virtual machine that allows you to recover the instance. Then you've got your multi-region replication, which is what I just discussed, that you can store your data in different regions, and always test your recovery. So most of the enterprises, they have simulated disaster recovery sessions where they say that, okay, let's simulate. Let's say our server has gone down. What are the steps that we need to take to get it back up? So simulate and see. PPT will be shared with you for sure. I think Kamna will be sharing the PPT with you once the session is done. So always, all the enterprises, they have simulated DR sessions where they actually simulate the disasters, and then they have their teams bring it back up, and then they see, okay, they were able to get back up in 2 hours, get back up in 6 hours, or it took 2 days. Then they try to have a RCA, root cause analysis, that how long, why did it take so long, and so on and so forth. So testing the recovery is also a very key part that a lot of DevOps and cloud and server management teams, IT admins, they do. So what have we seen so far in this session? We've seen the history of servers computing, where it came from, where cloud came from, then the different kind of services available in cloud, from virtual machines to your serverless computing to databases, storage, then some of the security policies like encryption at rest, IAM. Then we've seen disaster recovery, data backups, some costing. What does it really cost for you to have your application up and running per month? Use the pricing calculators. They will give you a fair idea. Also, point worth mentioning is that all the AIs that are available in the market today, like ChatGPT, Gemini, Claude, all of these, they are very, very advanced. You can always ask questions to ChatGPT or Gemini and ask it to guide you, that you're looking to build so and so platform or website or app. What technology should you use? And accordingly, you can use those AI tools to build your cloud. So AI is very advanced in this as well, very well trained on cloud computing. And this is where today we sit in cloud computing, and cloud computing is the core reason why AI and digital has become so popular and so big, is really because of cloud computing. If we didn't have cloud computing, it would have not been possible for all of these AI companies to have come in the market, or all of these, because without cloud computing, it's just impossible. You can't ask users to buy their own GPUs and run the AI on their own platforms, or their own physical locations. Because you have data centers on the cloud available, AI has become very commonplace. Now, some of the more common and more technologies that are in use today, will highlight a little bit about Docker and Kubernetes. So Docker is very common. How many here have heard Docker before? Do we have anyone who knows what Docker is? Containers, yes, that's exactly what they are. So when we look at where Docker has, where it came from. So what happened is, first we used to have server rooms, then server rooms moved into the cloud. Then inside those servers in the cloud, they made virtual machines. And Docker is basically, it's a virtual machine inside. It's like having a virtual machine inside a virtual machine that's inside a virtual machine. So basically, it's a container where the entire life cycle of your application it runs only within that container, and it is not affected by the other software that's within that same hardware. So Docker is a way to build once and deploy anywhere. So build once, run anywhere. Let's say you write a software, you write a website, or you write a mobile, or you write a platform that computes, let's say it does financial modeling. Now, if you didn't use Docker, for you to run that software on Windows or on Linux, and then installing all of those dependencies would be slightly of a challenge. But if you use Docker, you can package all of those things and you can just run the Docker image itself, whether it's in Windows, whether it's in Linux, whether it is in Mac, it's going to run. So Docker is a mode for you to package your applications, install all the dependencies within the container itself, and just run the container in any environment, and it will allow you to build once and run anywhere. And let's say you had 10 Docker containers that needed to communicate with each other. Let's say you had one that did financial modeling, then you had another one that sent data into a machine learning algorithm. From that financial modeling, it sent it into an ML container, and that ML container then sends it to a final dashboard tool which your users use. You can deploy all of these containers inside Kubernetes. So it is basically a net, it's a system for running multiple Docker contain. It's an open source system for automating deployment, scaling, and management of containerized applications. So let's say you had 8 Docker containers and you wanted to, and they all are linked to each other. You could deploy it inside something known as Kubernetes, and that will manage all those 8 containers for you, so that you can manage the life cycle, the amount of RAM, CPU, the resources that are granted to each of those containers within Kubernetes. So these technologies are also available on all of the clouds. Like cloud provides Kubernetes available. It's available also here. So if you see at the pricing estimator, you can see what it costs for Kubernetes. Oh, yes. And also just one very important thing to also see now that we are on this page, we can also see that all the clouds, they provide a little bit of free credits for you to get started. So you can see when you sign up with Google first, you get a $300 in free credits. So you can use these $300 to learn about the cloud, deploy some virtual machines, deploy some databases and so on, and see how everything works. Azure also provides some free resources, and so does AWS. So you can take a look at what's the trial that they provide. And yeah, each of these clouds provides Kubernetes. So you can see it's adoption of containers, and you can run containers which are standalone applications inside these Kubernetes clusters. They call it clusters because there are multiple containers that are hosted in that cluster. And it's slightly technical, but worth a reading if you want to see how very, very large scale applications, where applications that have typically hundreds of thousands or millions of users, they use Kubernetes, because this is something that's really enterprise grade, and it's really it's not very trivial or simple to set up as well, but it is very important if you want to have a really scalable application and infrastructure for and you can host it all on the cloud. It's a little bit about Docker and Kubernetes. They've become very popular in the past 5 to 6 years, worth reading a little bit about. All right, so what we've got we've seen cloud, where we've pushed all the workloads, server, infrastructure, everything to the cloud. We've seen all of that. Now there's another thing that's really also becoming popular, which is edge computing. So we've seen cloud computing, where we've taken a full-fledged server room and we've put it in the cloud, and now multiple thousands, millions of people can use that server room for their own applications at the same time. There is another mode which is known as edge computing. Now I will give you the example for edge computing, which is known as the self-driving car. That's a very, very good example for edge computing, because this is something that it's something that requires real-time analysis. It's not something where you can say that when the car is driving on the road and it needs to take a decision, that should it turn left or should it turn right, and should it is there somebody coming right in front. It cannot be sending the data into the cloud and waiting for a response, because what if there's a network lag, there's a network delay. So these kind of problems, these kind of use cases is where edge computing comes in. So edge computing brings computation and data storage closer to the sources of data. So this improves response time and save bandwidth. So now let's say you have your self-driving car. It's got its cameras and LiDAR sensors and everything attached to it. It needs to take decisions in real time, that if somebody is coming right in front of it, it needs to slow down, it needs to brake. Now you have your edge computing. Your decisions are made on those computers right at the edge. So typically you have now, because hardware has become, it's become quite advanced. You can, earlier, 20 years ago, 1 GB of RAM used to be a very, very common thing, a very, very a good thing. Today, 1 GB of RAM doesn't really mean much. Similarly, you've got GPUs, your graphical processor units. Basically, they do a lot of AI analysis. They're able to run millions and billions of computations in a second. And your CPUs have also really advanced. So you can have very complicated algorithms that maybe would take 5 seconds to run about 20 years ago. They can run at the fraction of a second today. There are some chips available in the market with edge computing. Now, you've got your common chips for edge computing. So this is one example which I've given you, a self-driving car. This involves advanced self-computing chips. Then let's say you've got IoT systems, Internet of Things. Who here has heard of IoT? Has anybody done any work with Raspberry Pi, IoT, NVIDIA Jetson? Anyone has worked with IoT systems? Okay. Okay, so somebody has done theory, somebody has worked with the... Okay. So let's say you had a farm, and the farm is 1 acre, 1 acre in size, and you wanted to control the water supply to the farm based on real-time information. By real-time information, I mean what is the moisture content at the farm at different times. So typically you can have your moisture content. Let's say you use the hose and you sprinkle the water in the entire farm, and it does the job. But what if some part of the farm has more moisture, and other part of the farm does not have as much moisture? So it's very, very difficult for a human being to monitor the moisture content in the farm manually in an entire 1 acre, or let's say it's an industrial farm which is like 1,000 acres in size. It's absolutely impossible for any human to go and check the moisture in each of those locations. But you can build IoT systems that can use moisture sensors, read the data from those sensors which are installed in different locations in that farm, and based on the amount of moisture content, let's say one part of the farm is drier than the other part of the farm, and those sensors, they can take the readings and they can accordingly send the decision to the the water connection, and they can say that, okay, at the top right corner we want only this much water, at the bottom right we need this much, at this part. So IoT systems, these chips which cost, you can get Arduino chips for like 500 rupees today, and sensors like these you can get for another 200-300 rupees. You can connect everything together, and you can have a automated watering system for the entire farm for lesser than few thousand rupees. That's an IoT system. You could have an automated temperature monitor inside a large warehouse. These are tasks that humans cannot do. It's impossible for a human to do this, monitor the temperature at 50 different locations the entire day. It's impossible. But an IoT sensor, it's just on and it's just reading the temperature and sending the data. So whatever is the data that's being returned, the decision in the air conditioning unit can be taken for that warehouse. That, okay, in this 1 million square foot size warehouse, in the top left location, the last left location, the temperature is low it needs to be slightly higher, because it's the humidity needs to be maintained, or the temperature needs to be maintained. So IoT systems, they can automate a lot of these difficult tasks, which humans, it will be very, very difficult for them to do. But IoT systems can do this, and this is exactly what is edge computing. So you can install some chips and sensors right at the edge where you need the data to be monitored and seen, and you can use these chips and sensors to get the information and then take a decision that do we need to increase the water or increase the temperature, decrease the temperature, increase the humidity, decrease the humidity, and so on and so forth. Or we are in a self-driving car, we need to stop the car, start the car, or move left, go right, reduce speed, increase speed, so on and so forth. So a lot of edge computing is a market that's really, it's just growing. It's really in its infancy. It's just starting in the past 2 or 3 years. It's when it started, and this is where it's going to start. It's going to keep growing. So if you would want to get started with edge computing, there are two very common chips. Raspberry Pi, you can get one for today you can get a 1 gigabyte chip for 6,000 to 7,000 rupees. And then NVIDIA Jetson, that has a GPU that's built in the chip itself. So if you needed more processing power, you can use a Jetson. So we have a question from Dr. Julie. Can we implement it in chemical industry to run a reactor with different operating parameters? Absolutely. Absolutely. I have worked with IoT extensively, and we have done these kind of projects where we have used IoT to take a lot of decisions in terms of the chemical content in water, or humidity systems, warehousing. So we can definitely implement it. I wouldn't say like easily, because it really depends on the kind of parameters, but it can definitely be implemented in the chemical industry to run a reactor with different operating parameters. Definitely, this is something that IoT is already doing, and it's just going to keep growing in the years to come. If you needed a little bit of AI processing, you can use an NVIDIA Jetson, Raspberry Pi. Both of these are very popular and very powerful chips. If you needed just basic decision making, like a microcontroller, you could just use an Arduino, and there's a Arduino or ESP32s and so on and so forth. So these are the IoT systems that are available in the market today, and it really depends on the use case and what problem you're looking to solve. And like we discussed before, that you have your compliances, whether you are in cloud computing or whether you are on edge, managing compliances. Security for your edge devices is important. You need to keep your edge device secure. Yes, Arduino Uno. That's a very common microcontroller system that you can use for these kind of tasks. The point I was also just making is security is very important. So whether you are, even when you're using your IoT, building IoT systems, keep your systems secure. So for example, if you're using an IoT chip inside a self-driving car, you don't want any outsider to be able to access that chip and take decisions that it's not supposed to take. So security is very important. We have a question about, can you tell in which part IoT queuing concepts? So typically, I think your question relates to the messaging, how IoT chips would send that data and receive data and so on and so forth. So since IoT is it's lightweight, and communication is very important. So we use a thing known as MQTT. That's a protocol that allows you to send very lightweight data. It's a few bytes of data that can be sent, and it's like HTTP. So we have MQTT, and you can queue the data inside MQTT. You can specify that, okay, it's always in a FIFO basis. So first in, first out, which is the data that arrived first, that will get processed, and so on and so forth. So there's MQTT. There are other protocols as well. There are some other lightweight protocols as well, but MQTT is by far the most commonly used one. And there are lots of services there's lots of services that can be used for such. COAP. Can you give me what's the full form for COAP? Okay. Any direction of simulation techniques based on this technique? So you mean for MQTT, simulation for MQTT? Okay, so constrained application protocol. I'm assuming you're talking about ensuring that your communication is lightweight. So that would be, you would ensure that your communication is only, your communication is only to the point. You don't send any data that's not needed. And typically, most of the data that's communicated in IoT systems, it is just in numerical format to ensure that it's as lightweight as possible. Sometimes we just use ones and zeros to communicate. One is a yes, zero is a no. So that would fall under your constrained application protocol. But ensuring communication is lightweight, that's very important to ensure that there is as minimal latency in any of the processing or any of the computation that needs to be done. And numerical data definitely it uses less memory compared to your string data. Numerical is much more lightweight. We had another question from any direction of simulation techniques based on this technique. So simulation techniques, you are looking for MQTT simulation. Okay, yes. So you can always simulate data with the MQTT. So MQTT provides a lot of clients. If you check out even on you can even simulate data. If you see on AWS, they provide a service called AWS IoT. And actually all the clouds provide, but AWS IoT is most commonly used as a proprietary IoT service. So when you use these, basically they provide this AWS cloud MQTT, and you can always see AWS IoT provide clients where you can simulate the data being sent into the IoT server or into the MQTT server. And once you simulate that data, that can allow you to see what the data actually does. So AWS IoT worth reading, worth checking out. And yes, latency means delay. You have to consider latency as if you're as lightweight your communication is, that's the best, so that the amount of traffic. See, IoT is one, LoRaWAN is another. So these typically, if you use just bits, that's ideal. You need to use bits, not bytes. And I mean, kilobytes is definitely out of the question, but keep your communication as lightweight so that it takes as low network bandwidth and it's as fast as possible. So yes, latency means delay. So yeah, AWS IoT is also a service that's offered here. I think Google also used to offer a Google IoT, but they have, I think it's Google Cloud IoT Core. And under the hood, they use the same protocol. So it's just products that they have offered, but under the hood, it's still MQTT, and your LoRa is like self. You create a network of your own. That's LoRaWAN. You can also see on Azure, they probably also offer. And services like HiveMQ. I don't know if AWS offers something in HiveMQ, but what we saw earlier, we had virtual machines. You can also deploy your own MQTT servers inside. Take a look here, introducing Google Cloud IoT, and this is from 2017. So I have not seen Google Cloud offering IoT. Let's see if there's still 2024. Yeah. But yeah, you can always take a virtual machine and you can install a IoT server inside or a MQTT server inside that virtual machine, and it will perform the same functions as if you were using a cloud managed service. Same as how you can host a database inside a virtual machine as well, and you can use the cloud managed services. You can also do the same thing over here. So that is definitely available. Any other questions, guys? There were some good questions that came here. Let's would like to hear some more questions. If I give my analytical model ChatGPT to communicate to simulation model, whatever coding is reliable. Yeah. So I would say to a good extent it's reliable. It may be not at the first attempt, but the technique that I always use is, okay, so whatever it gives, then I try to run it. Then whatever error I get, I give it back to ChatGPT and I try to get the answer from it. So it is reliable, but it can sometimes take 2, 3, 4 iterations for you to get the right coding. Any other questions, guys? So yeah, I use AI for coding like everyone else. I think it's allowed people to code very well, and yeah, I think it's yeah. Thank you. Can you explain how it's working a little bit? Which one? What is working? Suganti has a question. Simulation. So in simulation, what you do is, instead of using the real sensor to send the data, you use a little bit of code to actually just send the data to the endpoint. So your MQTT or your wherever you are sending the data, instead of reading the data from an actual sensor and sending it, you just simulate and you send it. So it's basically just sending the data using code. That's what the simulation is. Okay. Awesome, guys. So thank you. If no further questions, then
Thank you. Thank you so much, Aditya, for that session. And all the faculty members, thank you so much for attending and all good comments. Please do also, just record a little video of yours and send it to us so that we can also, put it on LinkedIn. You can also, tag us and Aditya on LinkedIn with your posts, and you can share how you like the session, and that'll be really nice. If some of you could put your little video and send us, we would really appreciate it. Right, Aditya?
yes, for sure.
Right. So please do that. That'll encourage us to, keep giving our best to upskilling you, and will also be very motivating for AICT to give us more such sessions, if I may say so. Thank you so much, Aditya, for that, and thank you, faculty members. I'll see you tomorrow again at 6 o'clock. Thank you.
Thank you, guys. Thank you.
Thank you. Thank you. Bye bye.
Bye.